Hello everyone, welcome to today's session. My name is Munduku Ansel and with me is
Nachimuni Penina. We are students of Makerere University doing Food Science and Technology, Year 1.
Today's session we're going to talk about minerals. A mineral is any inorganic chemical element that exists in ionic form, excluding the four elements which are carbon, nitrogen, oxygen and hydrogen. Minerals are categorized into two, namely macrominerals and microminerals, also known as trace minerals. Macrominerals are minerals that are required in large amounts. Examples include sodium, phosphorus, potassium, calcium, magnesium. Whereas microminerals are minerals that are required in little amounts. Examples include iron, zinc, copper, manganese, molybdenum, among others.
Now we are going to look at some of these elements.
We shall start with phosphorus. Phosphorus mineral is a mineral that is vital for energy transfer in form of ATP. It's also necessary in nucleic acid synthesis and is also a structural component of the plant cell.
Deficiency symptoms of phosphorus include muscle weakness, bone pain, while its toxicity leads to calcification of non-skeletal tissues like the kidney. Sources of phosphorus include all protein or animal protein sources like milk, meat, poultry, eggs, and many others.
That's all for phosphorus. Our next mineral shall be potassium. Potassium in plants regulates water uptake. It also regulates the opening and the closing of the stomata, and in animals it's also necessary for osmoregulation.
Too little of potassium can lead to irregular heartbeat and muscle weakness. It can also lead to glucose intolerance, while too much of this potassium can lead to vomiting, muscle weakness, and also it can be obtained from whole foods, vegetables, fruits, legumes, grains, and many others.
Our next mineral shall be calcium. Calcium in humans strengthens bones and teeth. It's also a component of the cell structure. It's necessary in the transmission of nerve impulses, and it also enables or helps plants in the uptake of nutrients.
Lack of calcium can lead to stunted growth in children, while it can lead to loss of bones in adults, a condition known as osteoporosis. Too much of calcium can lead to constipation and an increased risk of urinary stone formation. Calcium can be obtained from sources like milk and milk products like yogurt, cheese. It can also be obtained from legumes, grains, and small fish.
People say she fell and broke her hip, but in fact, sometimes the hip may have been so fragile that it broke before she even fell. This is a condition known as osteoporosis. This occurs when the bone loses calcium to the point that everyday stresses can cause fractures. Even bumping into a table may be enough to shatter a porous bone into pieces that cannot be reassembled again, and this may require you to get a major surgery. Unlike many diseases that make themselves known through symptoms such as pain, shortness of breath, diarrhea, skin lesions, tiredness, osteoporosis does not. The body sends no signals when the bones are losing their calcium, and as a result, their integrity. Worse, blood samples offer no clue because the blood calcium remains normal regardless of the bone content. So, dear friend, do not fall prey of osteoporosis, yet you can prevent it through eating calcium-rich foods like milk and milk products, cheese, yogurt, or some branded tofu.
Magnesium is another mineral. It's a component of the chlorophyll molecule, which is necessary for photosynthesis in plants. Magnesium also aids in enzyme activation.
Lack of magnesium can lead to difficulty in swallowing, weakness, and growth failure, while too much of magnesium can lead to dehydration, diarrhea, and alkalosis. Sources of magnesium include nuts, legumes, dark leafy vegetables, whole grains, and many others.
Moving on to the next mineral, sodium. Sodium is important in the body for the maintenance of body fluid and aqueous balance, aka osmoregulation. It also plays a key role in muscle contraction and nerve transmission.
Deficiency of sodium is not from inadequate intake, but is from excessive losses, a condition known as hyponatremia. Too much of sodium can lead to edema and acute hypertension. Sources of sodium include table salt, bread, processed foods, soy sauce, and many others.
Some processed foods may contain sodium without chloride, as in additives such as sodium bicarbonate, sodium saccharide. That's why they do not always taste salty. Most people are actually surprised to find out that 1 ounce of some cereals actually contains more sodium than 1 ounce of salted peanuts. But the peanuts may taste saltier because the salt is all on the surface. Thus, the tongue salt receptors pick it up easily and immediately.
Chlorine is yet another mineral. Chlorine is also important or plays a very big role in osmoregulation in the body. It also forms part of the hydrochloric acid in the stomach, which aids or kicks off the digestion of proteins.
Deficiency of chlorine is rare, but its toxicity can lead to vomiting. Sources of chlorine are similar to sodium, for example, table salt.
Moving on to the next mineral, iron. Iron is necessary for chlorophyll synthesis. It also plays a key role in electron transport in photosynthesis. It also forms part of protein hemoglobin, which is used to transport oxygen in the body.
Deficiency of iron can lead to anemia, pale skin, fatigue, and impaired immunity, while too much of this iron can lead to joint pain, infections, and GI distress. Iron can be got from red meats, eggs, shellfish, and many others.
A curious behavior seen in some iron deficient people, most especially women and children in low-income groups, is pica. Pica is the craving and consumption of ice, chalk, and other non-food substances. These substances do not necessarily contain iron and cannot remediate deficiency. Actually, clay, as mostly consumed by pregnant women here in Africa, inhibits iron absorption. And this explains why sometimes iron deficiency accompanies such behavior. Pica is poorly understood. Its cause most times unknown, but researchers hypothesize that it's motivated by maybe hunger, nutrient deficiencies, or an attempt to protect against toxins or microbes. The consequence of pica is anemia.
Our next mineral of discussion will be zinc. Zinc is a cofactor for various enzymes that are involved in DNA synthesis. It also aids in taste perception and wound healing.
Lack of zinc can lead to impaired immunity, hair loss, appetite loss, growth retardation, and delayed sexual maturation, while too much of zinc can lead to copper and iron deficiencies. Zinc can be obtained from protein-containing foods, for example, meats, poultry, fish, whole grains, and many others.
That's all for zinc. Moving on to the next nutrient, copper. Copper is necessary for electron transport in photosynthesis and respiration. It also plays a key role in lignin synthesis and also enzyme activation during redox reactions.
Deficiency of copper can lead to anemia and bone abnormalities, while too much of this copper can damage the liver. Sources of copper include seafoods, whole grains, and many others.
Manganese is yet another mineral. It's essential for photosynthesis and enzyme activation.
Deficiency of manganese is rare, but too much of this manganese can lead to nervous system disorders. Manganese can be obtained from nuts, whole grains, tea, and many others.
Molybdenum is yet another mineral. It's required for nitrogen metabolism, specifically nitrate reduction and nitrogen fixation. It's also a cofactor for several enzymes.
Its deficiency is rare and its toxicity has reproductive effects. You can get molybdenum from nuts, legumes, and cereals.
More to that, let's talk about iodine. Iodine is a component of the thyroid hormones that help to regulate growth, development, and metabolic activity.
Insufficient amounts of iodine can lead to goiter, mental and physical retardation in infants, a condition known as cretinism. Too much of this iodine can lead to underactivity of the thyroid gland. You can obtain this iodine from seafood, iodized salt, whole grains, dairy products, bread, and many others.
Goiter afflicts about 200 million people all over the world. In all but 4% of these cases, the cause is iron deficiency. As for the 4%, most have goiter because they consume excessive amounts of food that contain an antithyroid substance called goitrons. This is commonly found in cabbages and other foods, whose effect is not counteracted by dietary iodine. Goiter may be the earliest and most obvious sign of iodine deficiency, but the most tragic and prevalent damage occurs to the brain. Iron deficiency is the most common cause of preventable mental retardation and brain damage in the world.
Moving on to the next mineral, fluoride. Fluoride is essential in humans in that it strengthens teeth and makes teeth resistant to decay.
Lack of this fluoride can make one susceptible to tooth decay, while too much of this fluoride can lead to pitting and discoloration of teeth. You can get this fluoride from drinking water, tea, and seafoods.
Our second last mineral of discussion is chromium. Chromium enhances insulin action and improves glucose tolerance in the body.
Deficiency of chromium can lead to diabetes-like conditions, as we've heard, since it deals with insulin. You can get this chromium from brewer's yeast, whole grains, and many others.
Lastly, we shall talk about selenium. Selenium, which is an antioxidant, regulates the thyroid hormone in the body.
Deficiency of this selenium makes one susceptible to heart disease and the cardiac tissue becomes fibrous. Too much of this selenium can lead to a garlic breath odor, hair loss, and brittle nails. This selenium can be got from seafoods, fruits and vegetables, meats, whole grains, and many others. Speaking about food quality, it can be determined by appearance, flavor, texture, nutritive value, and many other factors. Have you ever tasted a chapati, rice, or any other food without salt? Oh my god, the taste is This is because salt brings out its own tangy taste and enhances other flavors in the food. This salt can also be fortified with iodine to prevent goiter. This same salt is used to preserve food as it reduces water activity. As you've already seen that at home you already salt your meat or fish or anything else to increase shelf life. This same salt is composed of sodium and chloride, which are minerals. In the same way, calcium fortified foods have a higher shelf life. Thank you.
Hello everyone, my name is Abigail, also a student of food science and technology. I'm here to talk about factors influencing mineral bioavailability, bioaccessibility, and stability. Starting with mineral stability, this is the ability of minerals to remain intact during various processing conditions. Mineral bioaccessibility is the fraction of minerals that is released from the food matrix into the gastrointestinal tract, while mineral bioavailability is the proportion of the released minerals that is absorbed and available for metabolic functions. Now let's get to the factors that influence those terms, beginning with nutrient to nutrient interactions. Interactions between different nutrients can impact mineral absorption. For example, consuming dairy products rich in calcium together with iron-rich meals may reduce iron absorption due to competitive binding in the gut. The source of the mineral can also impact mineral absorption. For example, heme iron, which is got from animal sources, is more readily available than non-heme iron, which is got from plant sources such as beans. Composition and structure of the food in which the minerals are naturally present impact their stability. For example, maintenance of calcium stability in dairy products is due to calcium being able to form complexes with casein protein. Presence of anti-nutrients also impacts mineral absorption. These compounds found in food inhibit mineral absorption. For example, phytates, which are anti-nutrients found in legumes and whole grains, form complexes with nutrients such as calcium and iron, hence inhibiting their absorption. Oxalates, which are found in foods such as spinach, form insoluble complexes with calcium, hence reducing calcium stability. Thank you.
That has been our discussion today as we talked about the classification of minerals, the examples, their roles, impact on human health, the sources of these minerals, and we also go to explore some of the facts about these minerals and also the factors that influence mineral availability, bioaccessibility, and stability of these minerals. Thank you for watching this video. Don't forget to give it a thumbs up and also subscribe to this channel. We remain students of food science and technology here at Makerere University. Till next time, build for the future.